Section 7.4, Solving Rational Equations. So now we're going to have an equal sign, which means we're going to need to solve for the variable. So how do we solve rational equations? Well, we like to get rid of fractions. So what do? We multiply every term by the LCD. This should eliminate your fractions. So we'll find the LCD, we'll multiply every term by the LCD, and that should get rid of my fractions. Therefore, I'll have an equation left. It'll either be a linear equation or a quadratic equation. Important you know the difference. A linear equation, you're going to get variables on one side and numbers on the other to solve. But with a quadratic equation, most of the time you're going to want to make it equal to 0 so you can try and factor. Step 3. Check your solutions by substituting your answer back into the original equation. Go back to your original, the one where you had fractions. If your solution gives you a 0 in the denominator, this is considered an extraneous solution. You cannot keep extraneous solutions because they gave you a 0 in the denominator. So let's talk about number 1. We have x over 5 equaling x over 2 minus 9. Looking at our denominators, we had a 5 and a 2. So we need to find the first thing 5 and 2 can all go into, which is 10. So my LCD is 10. So I need to multiply every term by 10 over 1. When I multiply by 10 over 1, that should cancel my fractions. Now the great thing about this problem is that my denominators, which are 5 and 2, are never going to change. So I don't need to worry about getting a 0 in the denominator. So 10 times x is 10x, but divided by 5 is 2. So I end up with 2x. 10 times x is 10x, but divided by 2 is 5. So I get 5x. And 10 times a negative 9 is 90, so I get minus 90. Make sure you multiply every term by the LCD, not just the ones that have the fractions. This is considered a linear equation, so I'm going to subtract the 5x to bring the x's to the left-hand side. So we get a negative 3x equaling negative 90. To get x by itself, I'll divide both sides by negative 3. And negative 90 divided by negative 3 is 30. I should check my answer. I'll leave you to do that, but it does check out. Number 2, y over 2 minus 4 over y equaling negative 7 over 2. So what are my denominators? There are 2 and a y. So what is my LCD? My LCD is 2y. Now there's one answer I don't want to get because it would make my denominator 0. For the y, if I got y being 0, that would give me a 0 in that second denominator. So be careful that you don't end up with y equaling 0 because that would be considered an extraneous solution. So we'll go ahead and multiply everything by 2y. Again, that's 2y over 1. Multiply and then divide. So 2y times y divided by 2 just gives me a y squared. 2y times 4, but divided by y just gives me an 8, so minus 8. And 2y times negative 7, but divided by 2 would give me a negative 7y. This equation is quadratic, so what do we need to do? Bring everything over to make it equal to 0. So I'm going to add over the 7y, and that should go in the middle. So we end up with y squared plus 7y minus 8 equals 0. So now this is just a C method. The factors of negative 8 that add up to a positive 7 would be positive 8 and negative 1. So it's going to factor into y plus 8 times y minus 1 equaling 0. Setting each of those factors equal to 0, I'm going to get y equaling negative 8 and y would equal 1. Neither of those answers would give me a 0 in the denominator, so those answers should work. So I get two answers for that second problem, y equaling negative 8 and 1. Number 3, 5 over x plus 1 equaling 4 over x plus 2. Again, we need to find the LCD. Well, my two denominators are x plus 1 and x plus 2. That's going to be my LCD because they can't be factored and there's nothing in common. So I'll need to multiply both sides by x plus 1 and x plus 2. So when I do so, the left-hand side, the x plus 1s will cancel. So I'll be left with 5 times the x plus 2. On the right-hand side, when I distribute, the x plus 2's will cancel, so I'll get 4 times the x plus 1. Then I'll go ahead and distribute my 5. 5 times x is 5x, and 5 times 2 is 10. Distributing your 4 times x is 4x, and 4 times 1 is 4. This is a linear equation, so I'll get variables on one side and numbers on the other. So I'll subtract the 4x to the left, I'll subtract the 10 to the right, so x is going to equal -6. Now, looking at my denominators, they were an x plus 1 and an x plus 2. So I would not want x to be -1 nor -2. Looking at my denominator of x plus 1, I would not want x to ever become -1. My other denominator was x plus 2, so I would never want x to become a -2 as my final answer. My answer is x equaling -6, so I'm okay. But again, always make sure that the answer you get does not give you 0 in the denominator. Number 4. 2 over x plus 5 plus 3 over x plus 4 equals 2x over x squared plus 9x plus 20. So what do we got to do? We need to find the LCD. So I'm going to come over here and use some of this space. So we have an x plus 5 as one of my denominators, x plus 4 is another denominator, and x squared plus 9x plus 20 as the other denominator. Well, that one can be factored into x plus 4 times x plus 5. So hopefully you'll see that that's your LCD. So I need to multiply every term by x plus 4 times x plus 5. That should eliminate my fractions. So when I distribute x plus 4 times x plus 5 times a 2, it's going to cancel with an x plus 5, so I'll just left with 2 times the x plus 4. When I multiply the LCD times the 3, the x plus 4's will cancel, so I'll be left with 3 times the x plus 5. And on the right hand side, x plus 4 and x plus 5 cancels completely with that denominator, so I'm just left with the 2x. So now I'll distribute 2 times x and 2 times 4, so I get 2x plus 8. Distribute the 3, I get plus 3x plus 15, and it still equals 2x. So this is just a linear equation. I'm going to let you finish out solving that completely, but I will give you the answer. The answer is x equaling -23 over 3. Is that answer okay to keep? Well, let's look at our denominators. Our denominators were x plus 5 and x plus 4, and then the factors of x plus 5 and x plus 4. So what values would I not want? I would not want x to be equal to -5, and I would not want x to be equal to -4. Did I get either of those answers? No. So I'm okay keeping x equaling -23 over 3. Number 5. X plus 3 over x squared minus 2x equaling 10 over x squared minus 4. First thing we need to do is find the LCD. So I'll take the x squared minus 2x and I'll try and factor that. Taking out an x, I'm left with x times x minus 2. The x squared minus 4 needs to be factored, and that can factor into x plus 2 times x minus 2. So what is my LCD? Well, let's just start with the first factors. We had an x times an x minus 2. Looking at the other denominator, it had an x minus 2, but it also had an x plus 2. So I also need to put in with the LCD the x plus 2. So my LCD is x, x minus 2, and x plus 2. So if it's easier, go ahead and rewrite your problem with the denominators factored. And then, hopefully, when you multiply by the LCD, you'll see things that cancel a lot easier. So now I'm going to multiply both sides by the x minus 2, and the x plus 2. So when I do so, I'm going to have the x plus 3. What's it going to get multiplied by? Well, it had the x and the x minus 2, so those would cancel. So it's going to have to get multiplied by the x plus 2. On the other side, the 10 had the x plus 2 and the x minus 2, so those would cancel, but it'd have to be multiplied by the x. Hopefully that makes sense. So now we'll FOIL this out. X times x is x squared. Outer gives me a 2x. Inner gives me a 3x. And last gives me a 6. Equals, and on the other side we get 10x. So we have x squared plus 2x plus 3x plus 6 equals 10x. Since this is a quadratic equation, we need to bring everything over, make it equal to 0, and combine some like terms. So we end up with x squared. Putting 2x plus 3x minus 10x together, we get a -5x. we still have plus 6 equaling 0. So therefore we need to factor. Factors of 6 add up to -5 or -2 and -3. So it's going to factor into x minus 2 and x minus 3 equaling 0. Setting each one equal to 0, we get x equaling 2 and we get x equaling 3. Now we need to make sure that both of these answers are okay to use. Looking at our denominators, which were x squared minus 2x and x squared minus 4, if I plug in x equaling 2, I get a 0 in the denominator. So x equaling 2 has to get thrown out. That's considered an extraneous solution. X equaling 3 is okay because when I plug it into my denominators, they do not give me a 0 down there, so I can keep x equaling 3. Number 6. 1 over x plus 2 plus 1 over x minus 2 equals 4 over x squared minus 4. First thing we need to do is find the LCD. Well, I had an x plus 2, I had an x minus 2, and x squared minus 4 will factor into x plus 2 times x minus 2. So I'll see that the LCD is the x plus 2 times the x minus 2. So what will I do with that? I'll multiply every term by x plus 2 times x minus 2. Again, it's over 1, so therefore when I multiply it, hopefully that'll cancel out my fractions. So when I multiply the LCD by 1 but divide by the x plus 2, I end up with 1 times an x minus 2. Plus, when I multiply the LCD times a 1 but divide by x minus 2, I get a 1 times the x plus 2. And then when I multiply the LCD times a 4, but divide by x squared minus 4, those are the same factors. They're going to cancel, and I'm just left with a 4. So let's go ahead and distribute the 1. Doesn't change anything, so I get x minus 2. Distribute the 1. Again, I get plus x plus 2 as well, still equaling 4. I'll combine like terms. X and x give me a 2x. Negative 2 plus 2 cancel out, and I get equaling 4. Divide by 2 on both sides to get x by itself, and x is going to equal 2. So again, I make sure that I'm allowed to use 2 in the denominator. In the first denominator, it's okay, because 2 plus 2 is 4. But in the second denominator, 2 minus 2 is 0. So I'm not able to use x equaling 2. That's considered an extraneous solution. Since there is no other solution left, my answer is no solution. Lastly, number 7. Y plus 3 over y squared minus y minus 8 over y squared minus 1 equals 0. First thing we need to do is find the LCD, so we'll take each of our denominators and factor. Y squared minus y, we can take out a y and we're left with y minus 1. The other denominator is y squared minus 1. That factors into y plus 1 times y minus 1. So for my LCD, I'll just take the first denominator, the y and the y minus 1, and I'll compare the other denominator to see if there's any other factor that needs to be multiplied in. Well, I see that there's y minus 1 there, but the y plus 1's not, so that's part of the LCD as well. So my LCD is y times y minus 1 times y plus 1. So what will I do? I'll multiply every term by y, y minus 1, and y plus 1. If it's easier to rewrite your fractions in factored form, I would do so, and then that might help you see what cancels and what is left. So I'm going to rewrite the equation as y plus 3 over y times y minus 1 minus 8 over y plus 1 times y minus 1 equaling 0. So when I multiply that by this LCD of y, y minus y, and y plus 1, let's see what we're actually going to have to multiply by. So the y plus 3 is going to get multiplied only by the y plus 1 because the y and the y minus 1 are going to cancel. Minus the 8 is going to get multiplied just by the y because the y plus 1 and the y minus 1 are going to cancel. And when I multiply 0 times anything, I just get a 0. So now we'll need to distribute. Y times y is y squared. Outer gives me a positive y. Inner gives me a plus 3y. Last gives me a plus 3, and I still have minus 8y equaling 0. Combine like terms, we have a y squared. Y plus 3y minus 8y gives me a negative 4y plus 3 equaling 0. So therefore it's quadratic. I'll need to factor. Factors of 3 that up to -4 are -1 and -3. So it's going to factor into y minus 1 and y minus 3. Setting each factor equal to 0, I get y equaling 1, or y would equal 3. Can I keep both answers? Well, let's check. Plugging in the 1 in the denominator, I get 1 squared is 1 minus 1. That's going to give me a 0. So y equaling 1 has to get thrown out. It's an extraneous solution. Does the 3 work? If I plug in a 3 in both of the denominators for y, it does work out, as in a sense that it doesn't give me 0 in the denominator, so I can keep y equaling 3 as my answer.